Alrighty then, so let's take a look then at the next set of wires, which would be the motor, right? And the motor wires are here. Now we've got a lot of extra. We got a lot of extra wires. This engine doesn't have a rear light, so we don't need the yellow wire. So I'm going to cut that. Right? This engine has got a motor, right? So we're going to need the orange. It's got a motor. Yes, it does. The orange and the gray wire go to the motor, right? So those two kind of twist together, right, and become the motor leads. Then we've got this wire, the green with the. Alrighty then, we're back, and sorry for the interruption there. Had a lost package today, so we're trying to find it. So here we are now with the orange wire, and as I said, the green and yellow stripe goes to the capacitor. So this has a capacitor on it, and we'll do that one with this and the blue. The blue is common plus, and it goes to the white, goes with the white wire to the front headlight. So so that is this one, right? And we had marked which one was white. Anyways, we'll get that squared away as to which one is the white wire, and we're going to put a resistor on this to make sure that that we don't have any problems with the LED and the front headlight. All right, we'll do that later. The next thing to do would be get the motor squared away. So motor contacts are going to be here. This is the gray one. And we've got an orange one. This is going to be the orange with the yellow and red tag on it. So let's do that one since that's pretty obvious. I'm going to move the tag down, and we're going to go ahead and solder that. Let's get them stripped and tinned. Here, again, going to leave myself a little bit of room. I'm going to use my strippers to cut it. And we're going to twist those two together. You know, we save ourselves some time. We don't need to tin it. If we're going to twist them together, right? So let's twist them together here. There you go. All right, now we can put solder on both of them at the same time. You know, it's up to you. This is a hobby, right? So do we want it to be pretty? Do we care about a customer is paying me to do this, and so I'm not getting paid by the hour? Well, I kind of am, but I don't usually charge by the hour. I charge by the install. I know about how long it takes me to install a decoder. Usually about an hour, especially a sound decoder. In this case, not as long because the speakers are already in. And I'm just connecting the speakers up. So usually I charge for about an hour's worth of work. Sometimes it's just this waiting on the hair dryer to take so long. It takes longer to do that than anything else. And this wire, which is the gray wire, right? So again, I know I know it's not gray tape. Sorry. You know, I looked for gray tape the other day in the store, thinking I could use that. They didn't have any. Don't know why. All right, and so this is the gray wire. I was thinking that was the white wire, but that's the, oh no, here's the gray wire. Boy, almost made a terrible mistake there. All right, so I want the gray and the orange to be about the same length, so I'm going to use the orange wire as my guide, right, and cut it here. All right, and then strip it. All right, and again, we're going to take a shortcut. Where's that wire? I just had it. Where's the black wire? There it is. And we're going to take a shortcut, and we're going to take these two, and we're going to twist them together, and then solder and put the heat shrink on them. Okay. And if I had been thinking, I would have done the soldering. I would have, twisted them both together and done the soldering at the same time, so that so I don't have to wait for the heat gun to do just one. Now I have to wait for the heat gun to do the other one. They would have done the two of them at the same time, because they were in the same proximity to each other. Okay? And now we wait. I'm watching the end to see when it actually starts to collapse. And one side of this is hotter than the other. I think that's because of where it is, where the nichrome wire is attached. Alrighty then. So now we've got the speakers attached. We've got the engine, the motor attached here, right? And we have the leads, the pickups attached. We're very close to being done. We've got the light now. So we got these two wires. The blue is always the plus. The white is always the minus. So I'm going to double check my connection here. I actually made a mark on it. It looks like a plus sign here. Plus and minus, right? So this is minus, this is plus. The minus is going to be the white wire. The plus is going to be the blue wire. So we're going to I don't want to mess that up by not marking it, and that's the reason why I had the white tape. So the white tape marks the white wire or the minus wire. So let's go back and make sure that we have that taped up. And I don't know if it's going to stick or not. It's been unstuck for so long. Okay, and we're gonna go ahead and cut that. We're going to cut this one, and this goes to blue. All right. So this goes to the blue wire. So we're going to again loop these around just a little bit. I'm going to cut that much off of it. All right. And we have this other situation going on where the blue wire is also attached to the capacitor. So as we and I need to kind of show that to you here. Let's see here. This is the diagram, right? Okay. So if you look at the diagram, you see the plus, right, goes to, well, oh, here it is. Common, V plus blue, right, goes here and connects all of those together, right? So that goes plus. And the minus is to the green yellow stripe. You see that on the diagram there. So that's what we're going to do next after we do this. But common blue wire acts as a bus, as a plus bus through all the functions. not just these front functions, but all the functions. And I did it again. Look at that. Stripper works great unless you pick the wrong hole, and then it either cuts it or it strips it, one of the two. So here we're gonna take these and we're gonna twist these together. But now we're going to do a little trick, because we want the capacitor to be in there too. And unlike a lot of other components, the capacitor marks minus. It doesn't mark plus. And so this broad stripe here and this big minus sign wants to make sure that you know that this is polarity sensitive. And because it's polarity sensitive, you have to make sure that the plus goes to plus and minus goes to minus. And so we're going to get it all done in one swell foop, as they say, right? And we're going to do that by trying to wrap this around that post. Okay. Now, I could use my wire wrap tool. We talked about this in another video, where I can put this in here and then put it around the post and go and twist it around that post. That's what a wire wrap tool does, except this is not really wire wrap wire. I really want to put it on this way. I want to put these together this way. And because I want to put them together this way, I'm going to go ahead and put a piece of shrink tube on this. It's the right size. I'm going to find the right size here. I think I'm going to cut a piece from my collection. All right. And so this piece is about the right size, and it'll go over this, and then I'm going to solder it to that and then pull it down over it. And actually we don't need all of this wire or all of this shrink tube, so I'm going to cut it in half, because I'm going to use the other half on the other leg of this capacitor. All right, so we got this and this. I'm going to go ahead and pre-tin those two. And actually, it's not pre-tinning at this point. It's putting them together, soldering them together. I know I'm doing it in the air, and it's kind of loosey-goosey. And you probably can't even see it. It's probably off camera. Okay, there we go. All right, and then we're going to put these on this capacitor. Now, this is going to be fun, because I got to hold the capacitor and hold the soldering iron and hold the wire and everything together to get it to work. I'm going to turn this around only because it's easier if it's going in this direction for me to solder it. Now remember, I got to solder it to the other side, the nether side, and I'm going to also pre-tin. I'm going to pre-tin the one that we're going to put the wire on, which is there. I might as well pre-tin the other one too while I got the solder hot and close. And now we're going to try to hold this while we solder them together. Oh, I almost forgot. I almost did it. I almost didn't put the shrink tube on it. All right, so hold on. Hold on. You almost saw me mess up there. Okay. Put the shrink tube on it. Like that. Okay, now we got to pretend we're ready to go right there. Oh, put a little bit more solder on it. Right. Stay with me. There we go. Cool. Can you see it? Yes. All right. So I'm going to do it right there. Cool. Just like that. Let it cool for just a second. Make sure that it's on there. And I'm going to take the shrink tube and pull it up and right over that pin. Okay, just like that. Right over the pin. There we go. All right, the other pin is going to have the green yellow wire, so we can bring that up and pull it up here. Let's see how long it is. All right, we're going to cut a little bit off the end of it. Don't need that much. All right, we're going to strip the wire. We're going to pre-tin it here. And we're going to, we need to put a piece of shrink tube on it. So let's get another piece of shrink tube. Now I can use the smaller shrink tube. I got a smaller piece here. When I say smaller, I mean smaller in diameter, right? So it's how many wires are you connecting? Okay, there we go. Cool, cool, cool. All right. We got this guy together. Let me see if we can. Yeah, we can even get closer here so you can see what's going on. A little grainy there, but all right. Now I'm going to try to do that right there where you can see it. Yeah, that's not going to work. I've got a little device here that's got some grabbers on it. Now you got to be careful what you grab. I'm going to grab the wire. I'm not going to grab the component. Grab the other wire like this that we've already done, right? Now I've got it turned around here where now it's not right because I'm using a soldering iron and using my left hand. So I really don't want it to be that way. I want it to be the other way. I'm going to use the other one. I'm going to turn this around like this. Right? We're going to grab it. Right? Kind of get it up there. Check and make sure that you can see what I'm doing. Right? So there it is, and you see the pin that's up on top. Right? So that's where I want it. Make sure that I've got the shrink tube down here at the bottom is connected. Right? And we're just going to solder this right there. Sometimes it pays to have a third hand. Matter of fact, I think that's what this thing is called. It's called a third hand. Right? And then you pick this up, and we're just going to put it right on that wire. Just like that. Just like downtown. All right, and then we've got the shrink tube. We're going to bring the shrink tube up. Come on. Come on. I know you can make it. Shrink tube up and connect right here. I'm going to let go and push it over. And just like that. Okay? And you see it now, right? There you go. And then we're going to heat all of that. Heat it all up. And the capacitor is not as prone to worry about the heat on it. Other components would be. And actually, every component you should be concerned about having heat on it for prolonged periods of time. You really should try to minimize the amount of heat that you put on any component, and especially on the system, the decoder. This doesn't, I don't know if this has got, doesn't look shrunk to me for some reason. Can you see that? Yes. Oh, that looks better. All right. How many more wires do we have left? One. We only have one wire left. Cool. Actually, we've got two. We've got one that's hanging out over here. This wire is a chuff wire, and this is not used in the tsunami. We could, lots of things we could do with this. Maybe someday later, right? Somebody will want to use it. We're going to go ahead and bring it into the cab with everything else, but I'm going to go and I'm going to put an insulator on it. What I'm really going to do is just take shrink tube and put it over top of the wire, fold it back on itself, and then kind of cap it off. So again, somebody may decide that they want to use this at a later time, so I don't want to. It's hooked to the engine and to how it was originally set up, and then we're just going to go ahead and shrink that as a cap and hold it. Alrighty then, you betcha. All right, so these are the only two left, and what I want to do is I want to make sure that there's a resistor in this path. And I've been leaving these wires deliberately as long as they were, right, from the engine, because we want to give ourselves plenty of room for flexing back and forth. It may create a problem for us later, we'll see. Got a lot of little pieces here. Do you know who the dirtiest, I mentioned this the other night, do you know who the dirtiest person is in a construction site? Yep, it's the electrician. The electrician, because all of these little pieces end up on the floor. After the electrician is in there, there's just little tiny pieces of wire and insulation all over everywhere. Anyways, and they never clean up after themselves. Somebody else will clean up. I can say that being an electrical engineer. Yeah, I can. I'm allowed. It's allowed. All right, so now we've got one wire left, right? It's the one that has the white tag on it, and it goes to the white wire, interestingly enough. But it has to have a resistor in between there. So we can use a 1,000 ohm resistor. I'm very partial now to these new ones, which are 1.3 thousand ohms. Because look at the size of these things. I mean, these things are tiny, right? Little tiny resistors. So we're going to use this. I'm going to put this back up in your site, and we're going to come back out a little bit so we can see what we're doing. And then I'm going to put that in line with the white and the white. These two wires here is going to go in line with it. So let me work on that. I'm going to find a piece of shrink tube that will go over that resistor. So when I get back, after I put these two together, there'll just be a bump. But inside of there will be this 1.3K resistor. Okay? So let's pause for a few minutes while I get that together. Okay, so here we go. I've soldered it on there, and I'm going to show it to you if I can find it. There it is. So there it is, right? And I've soldered the two ends and end to end. I'm just going to put the shrink tube over top of it. Right? And we're going to go ahead and shrink it. Now, why did we put the resistor in there? Well, first off, what comes out of most decoders is 14 volts. LEDs typically are in the 2 volt to 3.4 volt range. Now, there are some LEDs that you can buy that have an internal resistor, and you can see it doesn't take much, an internal resistor in them that will take 14 volts. And you can see now right here, right, how the resistor shows even through the package, right? Shows right there through the package, a little blister. So, so you need a resistor somewhere in the line in order to drop the voltage, or else you will, well, you'll burn out the LED. And the LEDs are much more costly than the light bulbs of old. So this is completed. All the wiring is done now. All right. What we need to do though is we need to dress this a little bit. So what we're gonna do is we're gonna take this back. So this is as far as these can be from each other, because we've got some constraints now that we're I picked a couple of wires, and usually the power wires are the ones that you want to constrain. The rest of them can kind of lay in there, not a big deal. You might say, well, it would be really cool if we could like put a piece of tape across here. A piece of tape right there would be ideal. All right. So why don't we get some Kapton tape? And Kapton tape is this stuff, right? Special made in 3M, or I don't remember, or DuPont, right? Came up with the Kapton name, Kapton. You can look it up on the net. And this tape sticks to metal. That's one of its characteristics, and one reason why we use it is because the adhesive on it is made specifically to stick to metal. That's good. Number 2 characteristic, especially for what we're doing, is that it has it is dielectric. In other words, it is non-conductive. So in case where you're putting wires together like this, you want to make sure that it's not going to conduct electricity and create problems for you. Well, alrighty then, we're at the end of this install, and we're ready to put it on the system and do a trial run. Alrighty then, we finished this up and we're ready to give it a little test. And the first thing we're going to do is check to make sure that the decoder is responding. So we've turned on our system and we have put ourselves in the mode here with the switch to be able to detect it. And we're going to check on our throttle now. Let's see, we'll do it this way. And we're going to say program mode. We're going to go PG and display. And it says 003. So add to 003 means two-digit address is 3. We're going to check and see if there's see what 29 is. 29, if you don't know, is the CV that tells us whether it's a 2-digit or a 4-digit address. And it says it is 2. 2 means it is a, 2 doesn't mean a 2-digit address. Anything below 32 here means it's a 2-digit address. So it's going to respond to 3. And so we're going to go ahead and turn it on at this point. So we're going to exit out of this and we're going to turn on the power. So power and plus turns it on, and we see the little dot there tells us that power is on. And we're going to come over here and we're going to actually flip the button to put power on this, and lo and behold, we have ignition, and we've got some sounds coming out. We're going to try the bell now. Over here, we're going to push the one and hear the bell. Whoop, whoop, whoop. I have to select the locomotive. So selecting the locomotive, select, and 3, and loco again. Okay, now bell. There we go. Got a bell, 2 whistle, and you can hear it, and it doesn't show anything there. And we're going to try to move it now a little bit. There we go. All right, movement works. Okay, turn the doggone bell off. Oh. All right, so we're in good shape. There's another locomotive up on the layout that's also 3. So the first thing we're going to do here is let's change this locomotive number. Okay, we're going to go ahead and I'm going to stop it while I take that other loco off. All right, and we're going to say 8 on that. There we go. Just silenced that was what we did. All right, so let's go ahead and change this locomotive's number. It says 290 on the side. So we're going to go up here and we're going to go to, again, program mode, program PG, right? We're not going to fuss with 29, but what we're going to do is push this button in, and this makes it add 4. We're going to say 290, right? So 290, and enter. And if we watch the locomotive, it should jerk just a little bit. And it came back and it said 290. I'm going to do it one more time. There we go. Writing, writing, writing. And it came back and it reads 290. So now let's go ahead and exit out, right? And on this locomotive number, right? Locomotive. And we're going to put 290 in there. 290 and enter. All right. And now we should get the same. We got to turn the power back on. So turn it on main. 290. Try and move it. Should respond to 290. Well, it would help if I put the right number in there. 290. There we go. Enter. I don't know if you could see that or not, but I put 2990 in there. Happens all the time, you know. All right, there we go. Good. We got a bell, right? Responds that, and responds to the whistle. Everything's in good shape. Should sound a whole lot better when we put the shell on. So, you know, I can do this. We'll turn the bell on. You can tell, right, as I put my hand over. I don't know if you can tell that or not through the speakers, but quite a bit of difference there between the two. Okay, good enough. We're ready to kind of block this. Oh, we got to check the front headlight. See if the headlight comes on. Watch, it'll probably blow up. Everything else would work. And oh, look at there. Light comes on and whoops. What? Why did it decide to move? Did I touch it? Let's try again doing that and see if it moves. No, I must have touched the button. Okay. Sometimes those things happen. You never can tell. All right, there we go. Alrighty then. We're ready to turn this baby off.